So mine is this one right here, the limit. You're trying to find the limit of this sequence here. Okay, so what you can do is because it doesn't really matter whether n is positive or negative, and then also these are all defined for when n is any real number, any real positive number. But I should say that it doesn't matter if if n were any positive real number, this would still be the same limit. So what you can actually do is just look at it in terms of x going to infinity, like that. And then this one is if as x goes to infinity. Wait, hang on, I meant to replace those with x's as well. Dang. Okay, so as x goes to infinity, this goes to 0, and that's going to go to 1. So this goes to 1, right? But then this goes to infinity. So you have 1 to the infinity, which is an indeterminate form, according to L'Hopital's rule. So what you do in that case is you consider the natural logarithm. And that's going to be limit as x goes to infinity of the natural logarithm is this. If you take the log of this, then this x comes down out in front like that. And then now we have this goes to infinity, but this goes to 0 because log of 1 is 0. And that goes to 0 as x gets larger. So it's infinity times 1 is what that one is. So, come on. So, what you do is you want to get it as 0 over 0 or infinity over infinity. And so the easiest thing is to take this to the denominator, like that. And now finally you have 0 over 0. So you apply L'Hopital's rule by taking the derivative of the numerator. So that's 1 over 1 plus 6 over x times the derivative of what's inside the derivative. That's 0. The derivative of this is negative 6 over x squared. And then the derivative down here is negative 1 over x squared. Okay, so this one, the derivative gives you that, just in summary. And this denominator, the derivative gives you this. Okay, now these x squareds are going to cancel. Those cancel. The negatives cancel. And let's see, what do we have? We have, when you cancel the easy stuff off, well, the whole denominator is canceled, actually. This whole the denominator is canceled. It reduces to 1. Okay, and then so up here you have what? You have 6 over 1 plus 6 over x, and that's going to go to 6. Okay, so we know that the natural logarithm of the limit is 6, which means if you take the exponentiate both sides, and e to the natural log of L is just L, and then e to the 6 is e to the 6. So that's going to be your answer.
Okay.
Any other questions that people might have? Okay, so today we're going to go to switch to series, and series is where you add up a sequence. That's sort of what you're doing, or that's what you think of it as, at least. And we could look at number exercise number 1 first. Let's look at that first, and then we'll try to explain some more things. So let's see. Explain the difference between a sequence and a series. So a series is where you're adding up a sequence. Okay, so a sequence is an ordered. It's not unordered. It's ordered. A sequence is not a sum. The sequence is an ordered list. Okay. Whereas a series is an unordered. No. Series is the sum of a list of numbers. Okay. Yeah. So it's this one right here. This fourth option. But technically, you can't take, if you want to look at it technically, you can't just add up an infinite number of numbers. Okay, that's just impossible to do. You can't take a calculator, and let's say you have infinitely many numbers, you can't put them into a calculator and add them all up. So what we do is add up the first n of them. So where n is like an arbitrary number, though. Okay, so this is the partial sum. S sub n, nth partial on sum. And so the variable here is the n. You're adding up the first n terms. So like if n is 5, you're adding up the first 5 terms. If n is 10, you're adding up the first 10 terms. If n is 1,000,000, you're adding up 1,000,000 terms, the first 1,000,000. And the series, this is the series right here. Okay, so series is where you're adding 1 to infinity or something to infinity. You're adding up infinitely many terms. That's a series. The series is technically the limit of the partial sums as n goes to infinity. So as this gets larger and larger, you're adding up. As n gets larger and larger, you're adding up more and more terms, and that's what your limit is. Okay, so let's take a look at number 2. Number 2 says, find the sum of the series. So here's the series. The partial sums are these. Okay, so the series is going to be the limit as n goes to infinity of the partial sums. Okay, so all you have to do is take the limit is that's supposed to be a limit. The limit is n goes to infinity of this. Okay, so what happens as n goes to infinity, as n gets larger, what happens to this? You're taking 0.6 and raising it to larger and larger powers. What happens to it? Anybody want to take a guess? Or anybody have an idea?
It approaches 0?
Yes. This piece goes to 0 because you're taking, because 0.6 is less than 1. That's the key. 0.6 is less than 1. So when you take things that are less than 1 and raise them to powers and you're increasing the powers, that's going to go to 0. So in the end, you're just going to be left with 5. Okay, and that's going to be the answer to exercise number 2. Okay, now let's take a look at number 3. So here we have a series, and they want us to find at least 10 partial sums. And they note what these are. They have values of n, and then you're supposed to find that. So let's go ahead and do that. Okay, so S1 would be you're just summing from 1 to 1. So you just want only the first term. So you just take n equal to the first value, which is this right here. So it's 4 over -3 to the 1. So that's going to be -4/3. Okay, so S1 will be -4/3. Okay, S2 will be where you're taking this -4/3, which was your first term, and you're adding when n equals 2. So if you put a 2 in for n, you get that. So, and that is going to be, I can put that into a calculator. I can put that on a calculator and it will give me a value. But what I think I'm going to do is the exercise, there's 10 of these, so that's quite a bit. So I don't want to be like adding up more and more numbers. It's going to get really nasty pretty quick. So what I'm going to do, so remember this is 4 over -3 to the n. What I'm going to do is open up Excel. Okay, I'll switch over to Excel in a second once I get it open. Okay, so I have Excel. Okay, hold on. Let me switch it over. Okay, so here I have Excel, and oh, wait a minute. Let me go back. There's something I want to do first. There's something I want to do first really quick. Or do I want to do this? Yeah, I want to do something. I'm going to do something that's going to make it easier first. Like, let me go back to this. Okay. Okay. Let me go to the first page. Okay. So I want to look at this right here when you have a geometric series. So here's what happens. Okay, so if I go 1 plus r squared plus r cubed, and I go all the way up to r to the nth. Let's say I do that, okay? Or n minus 1, we'll say. And let's say I want to know what that is. Okay, and that will be this is going to be my nth partial sum of something like this. Or actually, this right here, it's going to be a times all that. Okay, that's going to be my nth partial sum, and that's I'm going to show that it's going to be equal to this. Okay, so if I take this and I multiply by 1 minus r, I'm taking all this and I multiply by 1 minus r. Okay, then so imagine taking 1 minus r and multiplying it by each of these terms. So if I take 1 minus r and multiply the first term, it's 1 minus r, right? If I take 1 minus r and multiply by this term, it's r minus r squared. And if I take 1 minus r and multiply by that term, it's r squared minus r cubed. Okay, and going to keep going. 1 minus r times the last term is r to the n minus 1 minus r to the n. Like that. And now, a nice thing happens. You can probably see this, you probably saw this coming. That and that cancel, that and that cancel, this and the next one cancel. This one's going to cancel with the previous one. We're just left with a times 1 minus r to the n, like that. And this right here, divide both sides by 1 minus r, and I get this right here. Okay, so this is what it's going to add up to when I taking the first n terms, and when I have something like this. Or when I have something like this. It's better to maybe it's better to identify it like this. Look at this right here. Okay. So when you have a times 1 plus r squared and so on to the n minus 1, that is going to be a times 1 minus r to the n over 1 minus r when I have that situation there. Okay, so I'm going to show you how that comes up with exercise number. Okay, so just remember this right here. It's really important to remember that right there. That's what that, if you have that, you're going to get this. Okay, so if we look at this problem right here, when I set n equal to 1, I get negative 4/3 over negative 4/3, right? And then if I set, that's n equal to 1. Then if I set n equal to 2, I get this one right here. And then if I set n equal to 3, I have 4 over negative 3 to the third, and then so on, okay? Now, factor out a negative 4/3 from every single term, and I have 1. Okay, so if I factor a negative 4/3 out of here, then I'll have minus, or I'll say plus 4 over negative 3. I'll put parentheses around there for fun. And maybe, no, there's no, that's, the 4 is gone too. Oops. Factor a negative 4/3 out of that one, and I'm going to get 1 over negative 3 squared. Okay, and so on. And this is the first one, the second one, third. The nth one is going to be where I've got 1 over negative 3 to the nth power. Okay, so that's what that's going to be. Now, according to the first page, all of this is going to be 1 minus 1 over negative 3 to the n plus 1 over 1 minus negative 1/3. Okay, because here, if I'm going to the nth power instead of just to the if I have an n here instead of an n minus 1, then the difference will be, this will be n plus 1 right here. Okay, so whatever this power is raised to right here, you add 1 to it to go to that one. Everything else stay the same. Okay, so I got that. So that's what my nth partial sum is going to be. And I could simplify that. This is 1 plus a third, so that's 4/3 down there. Those 4/3 are going to cancel. And I get negative 1 minus negative 1/3 to the n plus 1. So that's what the partial sums are going to be. And I'm going to put those into Excel. I'm going to put this formula into Excel. So this is when n is 1, 2. These I'm going to make this the value of n. Because I want to do 10 of them. Okay, then over here, I'm going to go equals, and then I'm going to put what that was. Let me just a second. Okay, so it was negative 1 minus, and then it's negative 1/3 to the, and then put parentheses there, otherwise it's going to mess up, A2 plus 1. And then another parentheses to close that off. Okay, and then drag that down. That calculates all of them, and then it says round it to 5 decimal places. Okay, so if I move this over to the right spot, okay, that's 4. Okay, I adjust this until it's 5 decimal places. Okay, so every single one of those is 5 decimal places. And wait a minute, something's wrong. Oh, wait a minute. Just a second. I made a mistake with the formula. Oh, okay. Summing to here is when n equals 1. And this, summing to here would be, this actually corresponds to n minus 1, n minus 1. Okay. So this should be n minus 1 right here, which means that that's going to be just n, and that's just going to be n. Okay. So I messed up that way. So this should just be an n right there. So I'm going to go back to the Excel document. And I should just be raised to the A2 instead of A2 plus 1. Okay, and so those are all the answers right there. And round it off, because Excel did all the rounding for me. So basically, I can write them all down right here. Negative 4/3, negative 0.88889, negative 1.03704, negative 0.98765. Okay, so that's going to be, that is putting them all into Excel. Now, the next part is graph both the sequence of terms and the sequence of partial sums in the same viewing window. In the same viewing window. Okay, so what's happening is the first term is negative 4/3, and it's also the first, so the first term is negative 4/3. It's also going to be the first partial sum. So those it has to be either this one or this one based on that. It's not going to be that or that, because this is positive 4/3. So you throw those both out. Then from there, what happens is the next term is going to be here. Wait. What the? Oh, the next term is going to be here. Okay, so the blue ones are the terms, which is this right here. It's positive something. But it's not, but this distance from here to here is the same as the distance from here to here. Okay. So this is going to be the correct answer right here. So the next term is positive 4 over 9, which is a little bit less than 0.5. Okay, so maybe I can use a different color to denote that. Let me see. Okay, which is about, this is about 4 over 9. It's a little bit less than a half, so I'm not sure where it should be. Not more than a half like this one is, and this one's even the wrong color. And then this distance here should be, you're just basically adding this much to this value, and so on. Okay, and then the next one's positive. So then they alternate back and forth between positive and negative. Okay, good. Any questions about that one? Let's go on to number 4. Okay, so here we have difference between sequence and series. So this is a sequence. Anybody remember what this converges to? Oh, wait a minute. The previous problem says, does it appear the series converges? And in this case, it's going to converge to negative 1. Because as it goes to infinity, this goes to 0. So you're just going to end up with negative 1. Okay, so I'll move on. Number 4, anybody remember what this will converge to? This is just a sequence.
5/4.
Yes. So this one is yes, it's convergent. It converges to 5/4. Convergent. Well, it doesn't ask for that as a part of the answer, but you know. Okay, now they're talking right here whether the series converges, and in this case it's going to be divergent, because it's basically, if you took and you just kept on adding 5/4 up forever and ever and ever and ever and ever and ever and ever and ever, you know, it goes to infinity. It diverges to infinity. Okay, so but you're not really adding 5/4 up, but eventually you're getting numbers that are really close to 5/4 and just adding them up, and that's gonna, and we just keep adding that. It's infinite terms, and it's gonna go on forever. Okay, number 5. Number 5, determine whether the geometric series is convergent or divergent. Okay, so the thing about geometric series, I'll just say this right here. These are the partial sums. It converges if R is in modulus, in absolute value, if the absolute value of R is less than 1, and it diverges if the absolute value is greater than or equal to 1. Okay, so that's what happens when you have a geometric series, because these are going to be your partial sums, right? And if the absolute value of R is less than 1, then this is going to go to 0, and you'll get, and it will converge to A over 1 minus R. That's what it will converge to. But if the absolute value of R is greater than 1, greater than or equal to 1, then this is going, if it's greater than 1, then this is going to go up to infinity. So it'll diverge. If it's equal to 1, then let me think. Then you're dividing by 0 here. If it's equal to 1, if it's equal to negative 1, then it's bouncing back and forth between 1 and negative 1, and this is not going to converge. Okay. So if it's equal to 1, then it's just going to diverge. And if it's equal to negative 1, then it's going to diverge also. Okay. So you want the absolute value to be less than 1 in order for it to converge. Okay, so it says this is a geometric series. And so as such, what you want to do is take this right here and factor the first term out so you have a 1 right there. And then see what the other terms are. So you factor a 6 out. So factoring a 6 out of everything is going to give you 5, 6. Wait, let me just erase that. Plus, if you factor 6 out of here, you get 25 over 36, which is 5, 6 squared. And then this is going to be 5, 6 to the third, and so on. Okay. So the series is going to add up to 6 times 1 over 1 minus 5, 6. Okay. So here we have R is 6. No. R is 5, 6. And A is 6. Okay. And 5, 6 is there. Plus it's in all these powers right here. So it's A times 1 over 1 minus R is going to be what it converges to. And so that's 6 over 6, 6 minus 5, 6. So 6 over, that's going to be 1, 6 down there. Pull up to the numerator, it's going to 36. Okay, so this is going to converge, it converges to 36. Any questions about that? Okay, let's look at number 6. Determine whether this geometric series is convergent or divergent. So again, what you want to do is start writing terms out. So when n equals 1, what do we have? You put a 1 in here, you get -4 to the 0, which is 1, over 5. Okay, then when n equals 2, this is 2 minus 1, so that's going to be -4 over 5 squared. And then when n equals 3, you're going to get -4 squared over 5 to the third. Okay, and so on. So then what you want to do is factor the first term out of here, out of everything. Factor 1/5 out of everything. So it really looks like you're making things, maybe you're making things more complicated, but then the next term is going to be -4/5. And then the next term is going to be -4/5 squared. Okay, because this is a 3 right here. 5 to the third, and then so on. And -4/5 is what our R is, and what does that tell you? Converges or diverges if R is -4/5? So R is, and our A is,
It converges.
yes. Because it is less than 1 in absolute value. So this implies that it converges to A over 1 minus R, which is going to be 1/5 over 1 minus a -4/5. So that's 1/5 over 5/5 plus 4/5, or 1/5 over, that's going to be 9/5. The 5s are going to reduce, and you end up with 1/9 as the answer. Okay, so that answer should work. Okay, let's look at number 7. Determine whether the geometric series is convergent or divergent. Okay, so here, I don't know why they're calling it a geometric series. Maybe, and maybe that's a big hint, because I don't I don't think this is a geometric series, but who knows? Maybe it is. Because the problem is if I factor a 1/2 out, then it's not going to be. I've got these 3's here that are messing me up. This bounces between 1 and 3, 1, 3, 1, 3, 1, 3. And that's not good. The denominator is nice because that's 2. That's this 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th. But it just bounces back between 1 and 3. So there's a couple of ways that you can deal with this. You can split it up into 2 series. Now, you have to be careful when you do this because sometimes, like if you split it up if you do split up into 2 series and both of them converge, then the overall series is going to converge. But if you split up into 2 series and they both diverge, then like if it's a difference or something, then things might not work. Okay, but I guess if it's a sum and they both diverge, then the whole thing diverges. So maybe splitting up is fine. So we can split it up. So I'll let you guys choose. Do you want to? Well, I'll just do it. Okay. So we can split it up into 1/2. So we get rid of the 3's. Make them all 1's. Like that. Okay. And then add, and then we deal with everything else. So we had 3/4, but you only put a 1/4. So there's a 2/4 that we left out, and then there's a 2/16 that we left out, and then there's a 2 over 64 that we left out, right? Okay. So we have 2 different series. And these 2, like, because the 2/4 and 1/4 add up to 3/4. So everything is still there. Okay, so what we have to do is just figure out how to work both of these. So each of these is a geometric series. That's a geometric series. This is also a geometric series. Okay, so we factor a 1/2 out of here, and that leaves us with a 1 plus 1/2 plus 1/2 squared plus 1/2 cubed. This is really 1/2 to the 4th, but we're factoring one of those halves out. And that one, for this one, A is a half, and R is also a half. So it's going to be A, which is a half, times 1 over 1 minus a half. And this one over here, meanwhile, you can factor a 2/4 out. It's actually this 1/2. We'll factor 2/4 out, and then it's going to be 1 plus, let's see, and if I factor 2/4 out, that will be 1 over 4, right? And then this will be 1 over 4 squared, 1/4 squared. So this is a geometric series where A is 1/2, 2/4 is 1/2, and then R is 1/4. Okay, so this is going to add up to 1/2 times 1 over 1 minus a 4th. Okay, so let me see. This is going to simplify to that simplifies to 1. Oh, that should be a plus right there. Oops. Plus, what is that? 1/2. 1 over 3/4. See, that'll reduce that to a 2, right? So it's going to be 1 plus, and then this reverts to 2/3. So 5/3. Is that the answer? Yeah, 5/3. That's a really bad looking 3. It's not my fault. Maybe it is my fault. I should have chosen it. Maybe there's like a better program I could choose to do this. Okay, so 5/3. Any questions about that? Oh, wow. Okay, I take back everything I said. I copied this down wrong. This is not what the homework says, and that's not what the homework says either. Oops. And that's not what the homework says either. I was just like, this is just me preparing things wrong. And that's not a geometric series either. Oops. Okay, and that's all the mistakes. Okay, so all these mistakes that I made. Oh no. Okay, so number 8. Determine whether the series is convergent or divergent. Okay, I need some more space to explain a few things. There's a couple of concepts that I need to go over here. So maybe I'll say concept. Okay, so first of all, if the terms don't go to 0, the series diverges. Okay, that's a theorem in mathematics. What I mean by that, in this case right here, if you take, this is not going to be the series, but if I just take the terms, these are the terms, 4 plus e to the negative n. If I take the limit as this goes to infinity, then what happens is this part right here, the e to the negative n, is going to go to 0. And I get 1/4. So there's not going to 0. So eventually what's going to happen is I'm going to be adding 1/4 plus 1/4 plus 1/4 forever, and so it diverges. And it diverges because the terms don't go to 0. Okay, now that's first concept. So that's number 8 will diverge. The second concept is this right here. This series right here is called the harmonic series. It diverges. It's called the harmonic series. Okay. So that series, it diverges. And so what happens with this, when we do this exercise, is if we look at this right here, if you factor a 2 out, you get, and factor a 2/3 out, you get 1 plus 1/3 plus 1/3 squared. This part, this one converges. Okay, but this part here This diverges. It's the harmonic series that diverges. So overall, if you have a convergent, if you have a sum right here, and then if you split these up into series, and this one, and one converges, the other one diverges, then overall it's going to diverge because of course this will be a finite number, but this is going to blow up to infinity. So you have a finite number plus infinity, that's going to be infinity. Okay, so the overall it diverges. It's going to be divergent. Okay, so these two concepts, some people forget that. So some people, they'll take this and they'll be like, oh, if the terms go to 0, then it's going to converge, and that's not what that's saying at all. Okay, because look, these terms go to 0, but this diverges. These terms go to 0. So if you look at this right here and you go, oh, okay, I'm taking the limit right here. That goes to the limit then goes to infinity of 1 over n, which is what these terms are. That's 0. But this is not saying that that's going to converge. It only says that if your terms don't go to 0, then you're going to diverge. In other words, the only chance of converging is if your terms go to 0. But then it's not a guarantee. Okay, because here, these terms go to 0, but this diverges. Okay, any questions about that? And let's move on to number 10. And here's another concept called telescoping series. Telescoping series. Okay, telescoping. Again, and so what that is as follows. I believe that we've covered partial fractions before. So, but let me just kind of refresh your memory here. I'm going to change these to x's, okay, just because. So we did this, okay, we did partial fractions, and so and then at this point you set x, these have to hold for everything, so you set x equal to 1, and that gives you a is going to be 2, and you set x equal to -1, that eliminates that, and then this is -1, so negative 2b equals 4, so then b equals -2. Okay, and so that's basically telling you, and I can change these to n's as well. It's going to work because it worked for x's, it worked for n's. That basically tells you that what's inside here is this. B was -2, not +2, so this should be a minus right there. So I replaced that with this. Okay, now if I set n equal to 2, because it starts at 2, you have to look at where it starts. It starts at 2 right here. So if I set n equal to 2, then I get 2 over 1 minus 2 over 3. Okay, and then if I set n equal to 3, I get 2 over 2 minus 2 over 4. Okay, it doesn't look too impressive yet, but if I keep doing this, an interesting thing happens. So when it's 4, then this is going to be 3 minus 2 over 5. What the? And I hit the thing there. Okay. I gotta stay away from the edge. Okay, and then if I go n equals 5, then it's 2 over 4 minus 2 over 6. And then 2 over 5 minus 2 over 7. 2 over 6 minus 2 over 8. I can go on up. If I keep on going on up to, let's say the nth term. So here's n equals n. So I'll go n equals n minus 1 first. So then I get 2 over n minus 2 minus 2 over n, and then 2 over n minus 1 minus 2 over n plus 1. That's the nth partial sum, okay? Now what happens is I get my canceling pen out, and this and this are going to cancel. They're the same. This is a negative, that's positive. Okay, and then this one right here is going to cancel with that one. And then this one, wait a minute. Yeah, this one cancels with that one. And this one cancels with this one. And this is going to cancel with something up the road. This is also going to cancel with things. And what's going to happen is, okay, notice that this one and this one didn't get, they don't get canceled. This 2 and this 2 over 2. 2 over 1 and 2 over 2. They don't get canceled. Okay. But what's going to happen in the end is if you keep on looking at what does get canceled, is that's going to get canceled. And because the 2 pluses on the front didn't get canceled, that means the 2 minuses on the back didn't get canceled. So in summary, what you're going to have is your nth partial sum is going to be 2, this is this 2 right here, plus 1, that's 1, minus 2 over n, minus 2 over n plus 1. Okay, and if you take the limit as n goes to infinity of that, you're going to get 3, because those go to 0. Okay, and so your answer is going to be 3 in the end. Okay, any questions about that? So this is using partial sums. So that's essentially what we did here. We expressed the nth partial sum Sn as a telescoping sum. That's telescoping is where these things cancel. Everything cancels except the first a few parts of the beginning, or maybe just one part of the beginning if you're lucky, and then a few parts on the end. And then you have this partial sum, you take the limit, and that's just going to be 3. Okay, because these two go to 0. Okay, and then we just have one more problem, number 11. I think, let me run through this really quickly. If you have 3.99 and these 9s repeat forever and ever and ever, then that's actually gonna be equal to 4. And I'll show you in a second, but that's gonna be 4. And how many? That means the number 4 has 2 decimal representations because one of them is 4, and the other one is as 3.999 repeating. So that's 2. That one, 1, 2. 2 decimal representations. And here, all rational numbers that have a terminating decimal representation except 0 have more than 1 decimal representation. Okay, so let me explain this part right here. Sum a geometric series to find the value. Okay, so if you look at this, this is the same as 3 plus 9 over 10 plus 9 over 100, because that's the hundredths place. And then this is the thousandths place, so that's 9 over 1,000. And then 9 over 10,000, and so on. Okay. Now, I'm going to write as a 3. This part right here is where we have it's the start of a geometric series. So I factor a 9/10 out, and I have 1 plus 1/10 plus 1/10 squared plus 1/10 cubed, and so on. So I have a geometric series. A is 9/10, and R is 1/10. So that tells me that this is going to be 9/10 over 1 minus 1/10. Well, so A over 1 minus R. And the denominator is going to be 9/10, so it's 3 plus 1, then that's going to be 4. Okay.